Hi guys, this is Miss Brown speaking, and today we are going to start a new unit and we are going to talk about probability. So, as an introduction, we will talk about the theoretical of probability or the theoretical probability of simple events. So, what is probability? Probability is just a measure of the likelihood that an event will occur. For instance, what is the likelihood that it's going to rain? Could be a 0% chance, it could be a 100% chance. If I'm playing cards, what is the likelihood that I will be able to pick a green 3? How do we figure that out? Well, how do we express probability? Probability can be expressed as a ratio, and our ratio is going to be the number of favorable outcomes divided by the total number of possible outcomes. So, what's the ratio? I forgot. That was last year, right? Well, a ratio is a comparison of two quantities using division. In other words, it's just a fraction. Basically, when we're writing probabilities, we're going to be writing fractions comparing the part to the whole. For instance, this apparatus here is called a spinner. And notice the spinner has 1, 2, 3, 4, 5 equal sections. And this arrow, you're supposed to spin it and see where it lands. Well, on the spinner, notice here I have one purple section out of 5 total sections. So my probability of landing on purple would be 1/5. Well, what's an outcome? An outcome is any possible result. For instance, on this spinner, our possible results are to land on red or orange or purple or yellow or green. Are there any special math probability symbols? Remember, math is its own language. We have a symbol for everything. Well, kind of. We have a P, and notice inside the parentheses, we're going to write the event, and the event will change. Here we are spinning a spinner. We could be rolling a number cube and wanting to land on the number 5. We could be deciding if it's going to rain. This event will change, okay? This is just a general formula. So the probability of an event occurring is equal to the number of favorable outcomes divided by the total number of outcomes. So if I were to give you P and in parentheses red, I'm asking you what is the probability of landing on red? Well, I would look here and see, I have one red section out of 5 total. So my probability of red is 1/5. Can I only use a fraction to express a probability? Well, remember, if we have a fraction like 1/5, we can divide the numerator by the denominator, and that gives us a decimal of 0.2. And then remember, we studied percent, which means per 100. So I can multiply that 0.2 by 100 to get 20%. So to answer the question, a probability can be expressed as a fraction, a decimal, or a percent. So you want to make sure you read the instructions. If it asks for a percent, then make sure you're giving a percent. If it asks for a decimal, make sure you're giving a decimal. And if it asks for a fraction, make sure you're giving a fraction. And then if there's no specification, then you're kind of free to do as you please. All right. Well, when we studied percents, we sometimes got percents greater than 100. Can probabilities have percents greater than 100? The answer is no. The smallest probability you should ever get is 0%, and the largest is 100%. If we're talking about fractions and decimals, the smallest number you should get is 0 and the largest is 1. So it just depends on your number form, okay? Percents go from 0 to 100. Fractions and decimals go from 0 to 1. Well, what else do I need to know about probability? Well, probability can be described using the words below: impossible, unlikely, equally likely, likely, and certain. Well, how do we know which word to use? Well, we have a graphic here that helps us. If your probability is 0, then we would say it's impossible. It has to be exactly 0. For instance, if I were rolling a 6-sided number cube, 6-sided number cube has the numbers 1, 2, 3, 4, 5, and 6. And I ask you, if I roll this cube, what is my probability of getting the number 8? That's impossible because there is no 8 on the number cube. That would be a 0% chance. Now let me jump to the other side to certain. If I have a fraction of 1 or a percent of 100, that would be described as certain. For instance, if I ask you, well, I'm going to roll this number cube. Remember, it has 1, 2, 3, 4, 5, 6. And I ask you, what is the probability of the cube landing on a number? Well, that's certain because that's the only thing that's on the cube is numbers. Now I'm going to jump to the middle to equally likely. Equally likely has to be exactly 1/2. For instance, if you flip a coin, what is the probability that the coin will land on heads? Well, there's 1 head out of 2 sides, so that's 1/2 or 50%. So remember, impossible is exactly 0. Equally likely is exactly 1/2. Certain is exactly 1. But what about all this stuff in between? Well, anything that is greater than 0 but less than 1/2 is unlikely. And I'm actually going to switch and use percents for this because sometimes I think we understand percents better. For instance, if I told you there was a 5% chance that it's going to rain, 5% might be about right here on my number line. Even though it's very close to 0, it's still described as unlikely because all of this stuff right here is unlikely. If I told you that there was a 49% chance that it's going to snow this Friday. They are calling for snow, by the way. And 49% chance, that's still described as unlikely. Even though 49 is very close to 50, it's still unlikely. Now, let's jump over here. All of this stuff, that's greater than 1/2 or 50%, but less than 1 or 100 is called likely. So if I told you there was a 55% chance that Miss Brown would bring you donuts tomorrow morning, that would be described as likely. Even though it's very close to 50, that would be described as likely. If I told you that there was a 99% chance that you were going to win the lottery, that would be described as likely, even though it's close to 100. Alrighty, so I hope this helps. Have a wonderful day. Bye-bye.